Alright, so in this video I'm going to talk about some idealizations that we use in statics. So why would we idealize things? Well, in truth, the real universe is very complicated, and there are lots of things going on that either we can't fully describe with equations, or the equations that do describe them are so complicated that to solve them would be ridiculously long. However, in engineering, often what we need is a good enough representation of what's going on. So quite often, if I can find my mouse, if we can simplify things, we can write simple equations. Simple equations. Alright, so simplify things, simple equations. Why do we want simple equations? Well, to put it bluntly, we can solve simple equations. And we can solve them in a reasonable amount of time. Now the trick is to idealize things in such a way that we get to simplify them in such a way that we get simple equations that we can solve and still have the solutions be relevant to what's going on. Okay, so that's a trick. And there are three primary idealizations that we talk about in statics. The first is we idealize some things to particles, right? Particles. So what's a particle? A particle has mass, but no volume. Okay, so it has mass but no volume. You say, well, Dr. Davis, what good is that? Well, basically what we're saying here is that the sum of torques, right? So if it has no volume, it can't spin. Spinning is meaningless to it. The sum of torques is not really important. So you'll see that there are some systems that the only thing we care about is that one equation, that sum of force equation. So statics is already pretty simple. There's only two equations we have to deal with. We can make it even simpler by saying, look, only this equation really matters. Only this equation really matters. Okay. Second idealization is this concept of a rigid body. So we said, you know, there's no such thing as a rigid body. Everything deforms. What do we really mean by deformation? Well, we mean if there's 2 points on the body and something happens to the body, then those 2 points are still the same distance away from each other. So a rigid body is idealized by saying it's made up particles whose relative location is fixed. So what we're saying is if we start out with two particles making up this rigid body and they're located 2 inches apart, no matter what we do to this body, they're going to stay exactly 2 inches apart. Of course, we typically have a large ensemble of particles, millions and millions of particles, but the relationship of any particle to any of the other particles stays the same. Okay, so the relative location is fixed. Oops, fixed. There we go. All right. The third idealization is this concept of concentrated forces. Concentrated forces. All right, so the best way to explain this is, let's say I have an automobile, or in my case, I can't really draw an automobile. Oops, can't really draw an automobile. I'll draw a truck. And I look at what's going on at one of the tires, right? So here's what's going on at one of the tires. We're going to blow this up. What we really have is a tire, but it's a little deformed where it meets the road. And at every finite point that there's contact, there's force between the road and the tire, right? That's kind of complicated. Now we've got to, when we do this sum of forces, we've got a whole bunch of forces we've got to add up. It sure would be nice to simplify that. So what we do is we say, look, the tire can be deformed. That's not really a big problem for us. Okay? So, but we're going to treat it as rigid. Once it's deformed, it's fixed there. We're going to say it doesn't change. Nothing happens. But all these forces we're going to replace with a single force that does the same thing. So we're going to find some force concentrated that is equivalent to the sum of all those individual forces, right? So we take all these individual forces and we do something to figure out a new force that's equivalent to those. So those are the three idealizations that we're going to deal with in static. The concept of particles, treat things as rigid bodies, and later we'll talk about getting these concentrated forces.